Hi everyone, this is the final report for our Q&A system. Let's start with pre-processing and the external tools that we used. So later in the presentation, we may refer to things such as post tags and different verb forms without repeatedly stating how we get them. Now, question generation. For foreigners who learn to ask questions in English, the first thing is always to learn to make a yes-no question from a statement. And the key to that is to focus on verbs. So we can search for be verbs from the sentences in a passage, and then check for the noun that precedes it is a proper noun. After that, we can simply reverse the subject and the be verb to form a question. For regular verbs, we have to pay a little more attention to the tense of the verb, which we can conveniently see from the post tags. Then we'll just have to form the correct question with the base form of the verb and attach do or have of the right tense to the front of the question. Last but not the least, there's always the shortcut way to form a question in English, which is just to raise your tone. But that's not going to show because we're dealing with a text system, so we simply attach is it true that in front of a sentence and question mark at the end in place of raising the tone. It looks kind of vacuous, but it basically ensures that we will always generate enough number of questions from every given passage so that we can focus more on the quality of our questions and consider how difficult they are to answer. So for binary questions, we realize that the negative answer questions are harder because when comparing the target sentence to the question, the system will have to tell apart whether the difference is syntactical or factual. And another aspect is whether the question is textual or general. So as we have introduced, the questions that are transformed from a specific statement in a passage is really easy for machines to answer. In order to generate general and negative binary questions, we look at some of the keywords. To ask questions that are general but with a definite answer, we look at the subtitles of the passage. So there are two types of subtitles that are helpful for forming questions, which are noun phrase subtitles and preposition phrase subtitles. We can combine them with the main title of the passage and ask questions such as, has the passage discussed the design and characteristics of the subject, or has the passage discussed the title subject in printed adaptations? For generating questions with negative answers, we substitute the numbers in statements for the is it true that type questions. It will be interesting to try mix up other information from the same passage, but numbers is the easiest thing to mess up with that doesn't interfere with the correctness of the question.
Here's an overview for the WH questions ranking and grammar checking processes. These steps allow our system to generate questions that find the appropriate balance between enough context and conciseness, as well as avoid ambiguity and find the best ones. We find this order of operations combined with the binary questions generated previously to provide the most optimal results. I'm going to walk you through a few examples of our system in action. For who questions, we consider two main cases, where the person is the subject and where the person is the object. We identify where the recognized person object is in the sentence and note the preceding words. If the person is not preceded by any words, most particularly by, we can directly make the change to the question. When the object is preceded by, however, we reframe the sentence to become a question, as shown. When necessary, we also alter verb tense to the infinitive. We perform similarly for when questions. We isolate date entities, look for specific in or on date situations and their clause, identify its and the verb's location, then assemble the proper syntax by adding when. As shown, the inclusion did is a general rule and thus can be applied with great accuracy for a lot of situations. If there is a replaceable pronoun at this stage, the loop for the sentences comes in handy to locate the correct proper noun. This trumps replacing all the pronouns at the start, which decrease fluency from the constant name repetition in a question. Some other smaller categories we implemented in similar manners were how many questions, which we identified with quantity labels, why questions, which we identified with the word because, a general reasoning for something, and what questions, which were also generated in other steps like when, asking what happened on a specific date and alternate names or explanations for them. For ranking the questions, we used a point system for all the previously generated questions. We gave points for named entities which we thought indicated general clarity and correctness. Based on empirical results, we identified features in suboptimal sentences, which we balanced and docked points for specifics as shown. Our ranking system is the best because we didn't rely solely on technical rules, but adjusted our system based on the raw results that are provided. Last, we performed a grammar check where we attempted to correct insufficiencies in the labeling process and made cosmetic adjustments without changing the content too much. This ensures our generated questions at least look their best.
Here is our answer system. And this is the overall roadmap. After reading the text file, we will replace the personal pronouns in the text with full names. And then we will tokenize the parse text into sentences and construct predicate dictionary from these parse sentences. Given a question, we will parse it and get the question type. We will first try to find a match sentence in the text after removing stop words. But if there is not a match, we will simply refer to the pre-constructed dictionary and try to find the answer and construct a fluent and reasonable one. Here are the basic tools we are using. The basic idea behind this step is to replace he and she with the nearest person's names that have appeared before. And for each sentence in the text, we will first use Stanford parser to get the tree structure of the sentence. And then we will be adding items to the dictionary. So first we will extract the subject noun in the sentence, and then it will point to a list of tuples which consist of predicates followed by other conditions. Given a question, we will first try to match it to one of the three different types: binary, when, where, and what and who. We will simply be returning the question type followed by a declarative sentence extracted from the question for the convenience of next steps. For different types, we have different methodology for parsing that. For binary questions, we will check subject, predicate, object, and also negative or affirmative. And we will simply be returning yes or no. For when and where questions, we will check the same items as above, but we will be returning adverb. For what or who question, we will first check predicate, negative or affirmative, and because what or who will match one of subject and object, so we will be checking each of them and returning the other one. Thank you for listening.